Welcome you all to the video laboratory series. I am Professor Amit Kumar Patil, Assistant Professor from Department of Electronics and Communication Engineering, School of Engineering and Sciences, MIT Art Design and Technology University, Pune. Today we will study a topic from the subject Signals and Systems. So the name of the topic is Introduction to Signals and Systems. Here we will study about what are signals, what are systems, what are their different types and their classifications. So let us come to the topic. So subject name is Signals and Systems. Subject code is 23EC2322. So there are total 5 course objectives for this subject. First is to learn the concepts of basics of signals and systems. Second, to study continuous time and discrete time signal of LTI system. Third is to understand the analysis of continuous time signal using Fourier series and Fourier transform. Fourth is to understand the analysis of continuous time signal using Laplace transform. And fifth is to learn the analysis of correlation functions, probability, random variables, and random signals. So unit number 1 is basics of signals and systems. So in this unit, basically we were study about what are signals, what are systems, what are the different types of operations which will be performed on the signals, what are the elementary signals, and the classification of systems. Unit number 2 is continuous time and discrete time domain of LTI system. So here we will study about the LTI systems, convolution, their properties, and we will solve some numerical problems on this unit. Unit number 3 is continuous time Fourier series. Here we will study about what is Fourier series and what are the Fourier transform and their applications. Unit number 4 is Laplace transform and its applications. Here we will study about what is Laplace transform, its properties, how to solve the numerical problems using Laplace transform, its applications, and the inverse Laplace transform. Unit number 5 is correlation functions, probability, random variables, and random signals. So here we will study about what is autocorrelation, cross-correlation, probability, random signals, random variables, cumulative distributive function, probability density function. And there are total 5 course outcomes. So first is apply different types of operation on signals. Second is to evaluate the system-based properties and compute convolution. Third is to analyze the signals in the frequency domain using Fourier transform. Fourth is to apply and calculate the Laplace transform of different types of functions. And fifth is evaluate probability functions and statistical averages using random variables. So let us come to the topic Introduction to Signals and Systems. So a function of one or more independent variables which contain some information that is known as the signals. So basically it is an information carrying signal. Different examples like electric voltage or current, radio signals, TV signals, telephone, sound signals, and etc. So and system, basically it is a set or functional block that are connected together and produces an output response to an input signal. So it is a combination of different types of functional unit which produces a desired output for a given input. Examples are like audio amplifier, attenuator, TV set, transmitter, receiver, machine, etc. So there is a relationship between signals and systems. So every system has one or more inputs and it is known as excitation. And every system has one or more outputs, it is known as response. So signals are basically classified into two categories, continuous time signal and discrete time signal. The signal which is continuously defined in a time domain and which can be represented all the time intervals, that is known as the continuous time signal or analog signal. And discrete time signal, the signal which is defined only at some specific time interval. Thus amplitude of the signal will exist only at some given time intervals, that is known as the discrete time signal. So this continuous and discrete time signal, they are classified into 4 categories: deterministic and non-deterministic signals, then periodic and non-periodic signals, even and odd signals, and energy and power signals. So the signal which can be represented by a mathematical equation, they are known as the deterministic signal, like sine wave, cosine wave, exponential signal, etc. And the signals which cannot be represented by any mathematical equation, they come into the category of non-deterministic, or they are also known as random signals. Example, noise. Second is periodic and non-periodic signals. So the signals which repeat itself after regular interval of time, they are known as the periodic signals. The signal which cannot repeat itself after regular interval of time, they come into the category of non-periodic signals. Next is even and odd signals. A signal is called even if the inversion of the time axis does not change the amplitude of the signal. They are also known as symmetric signals. So for even signals, xt is equals to x of minus t for continuous time, and for discrete time, x of n is equal to x of minus n. A signal is called odd if the inversion of the time axis inverts the amplitude of the signal. The odd signals are also known as anti-symmetric signals. So x of t is minus x of minus t for continuous time, and x of n is minus x of minus n for discrete time. And this is the formula to calculate the even part and odd part of the signal. Even part is given by xt plus x of minus t divided by 2, and odd part of the signal is given by x of n plus x of minus n divided by 2. Energy and power signal. The signal is called energy if it has finite and non-zero energy. So energy is given by integration minus infinity plus infinity mod of xt whole square. A signal is called power if power is finite and non-zero. So formula is limit 1 by t integration minus t by 2 to plus t by 2 mod of xt whole square. So this is about the signals and systems. Now let us see what are the different types of the systems. So systems are classified into following categories: linear and non-linear system, causal and non-causal, static and dynamic, time invariant and time variant, stable and unstable, and invertible and non-invertible system. The system which satisfies the superposition principle, they are known as the linear. Otherwise, they will be a non-linear. Superposition principle is given by f of x1t plus x2t is equals to f of x1t plus f of x2t. Means response to the sum of the inputs is equal to sum of individual responses. Causal and non-causal, the system in which output depends upon present and past values of the input, they are causal. And the system in which output depends upon future values, they are known as the non-causal. Static and dynamic, the system in which output will depend only on the present value of the input, they are also known as static or memoryless, like x of n. And the system in which output will depend upon past and future values, they will be the dynamic system or memory system, like x of t minus 1 or x of t plus 2. The system in which shift in the input results in the corresponding shift in the output, they are called time invariant system. And otherwise they will be non-invariant. Stable and unstable, the system which for every bounded input produces the bounded output, they are known as stable system. Otherwise they will be an unstable system. A system in which there is different output for every different input, they are invertible. If they are getting same output for different inputs, it is non-invertible system. So it is about the classification of the signals and systems. So that's all about today's lecture. See you in the next session. Thank you.